In this question, you are asked to find what is the dependent and the independent variable. By looking at the data given, student was asked to study how much sugar can be dissolved in 100 milliliters of water at different temperatures. The results are in the graph below. Answer questions A to C. You can see that the temperature is one variable, and the second variable is the grams of sugar that dissolve in 100 gram water. The graph shows that as the temperature increases, the number of grams of sugar that dissolve in water increases. And this means that it's directly proportional, like the grams of sugar dissolved in water are directly proportional to the temperature. Or, in other words, you can say that as the temperature increases, the solubility of sugar in water increases. The question is asking here, what is the dependent variable in this investigation? And the second question is asking about the independent variable. So what affects what? Temperature makes sugar dissolve faster in water. So temperature is the variable which affects the solubility of sugar in water. So I will say that temperature is the independent variable, while the dependent one is the solubility of sugar. Or you can just copy what's given on the y-axis. And he is asking, justify your answer. So why you have chosen it? So I will say because solubility increases when temperature increases. Answer this question to justify your answer. So why you have chosen temperature? I will say because change in temperature affects solubility. Or you can say that solubility is directly proportional to temperature. Identify the factor that was kept constant during this experiment. In this experiment, we are measuring the effect of temperature on solubility of sugar. And you got a graph like this. You are comparing changing in temperature with the solubility. So you need to keep all other variables constant. For example, amount of sugar. You should not change amount of sugar when you are repeating the experiment. You should not change the time of the experiment. You should not stir. So you cannot leave one experiment, leave the sugar without stirring, and stir in the second one. All those variables, if you change any of them, your experiment will not be reliable. Students calculate the density of substance to 10. So the measured value was 10. The accepted value is 20. Calculate the percentage error and report your answer to the correct number of significant figure. The first thing you need to write the formula. Error equal the measured value minus the accepted one. Measured value is what the student has measured, 10. Accepted value is 20. So the error is minus 10 gram per ml. After that, you need to calculate the percent error. Percent error equals the error divided by the accepted value multiplied by 100. If you do this operation, 10, the error, the accepted value is 20, multiply 100, so you will find it, divide by 2 equals 50, so the answer is 50%. Question 15. A student measured the volume of a liquid as 1.8 milliliter if the percentage error in the student measurement was 20%. What is the accepted volume of the liquid? Going back to the formula, you will recognize that the error is, if the percentage error is 20%, means in every 100 results, I have 20 times I am doing a mistake. Means you are doing 2 mistakes in every 10 measurement, or you are doing 1 mistake every 5 measurement. This means that the percent of error in every 10 times you are taking the measurement, you are doing the mistake twice. So the error here equals 2/10 or 0.2. You know that the error equals the measured value minus accepted value. By doing very simple calculation, you will recognize that the accepted value is 2. This question seems now very simple to you. He is asking about the number of significant digits in the following measurements. Okay, cancel this. 1, 2, 3, 4, 5. Here, 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, I corrected the first one because this 0 is counted as it's coming after the decimal place. But all those zeros are not counting. I have done some of the operations, so you can practice them later on. Here, we resume again. Very simply again, all zeros on the left are not counting. Zeros on the right are counting only if they are coming after a decimal place. The whole number is counted. Okay, the 0 on the right is not counting if there is no decimal point. Remember that we cannot ignore zeros twice on right and left. In this operation, we cancel out the zeros on the left. You cannot cancel again this 0. It should be counted this time. In this question, he is asking to round all your answers to 3 significant digits. In order to round these to 3 significant digits, what we shall do, I can make it like this. 1.2, 0, multiply 10 power. Recognize in order to make this number 1.20, we moved 5 decimal point to the left. So here you should write 10 power 5. Okay, in order to round this to 3 significant figure, I need to round 7. It's more than 5, so the 5 will be 6. And now we have only 3 significant figures. This question number 21, you need to round it to 3 significant figures. So very simply, you're going to move the decimal point the correct number of places until you have only 3 significant figures. You will not be having in the beginning 3 significant figures. You will be having a number like this, 8.769. So we have 4 significant figures. 9, it's more than 5, so this number will be turned into 7. So it will be 8.77. And as we move to the right side, so the power will be in negative, according to the number of places you have moved. This number to 3 significant figure, you write the first number, normally, you write the second number, and you will stop now, looking for the third number. Okay, I have 3 here, but this number is 6, more than 5, so the 3 will be 4. The same way, 5 is will be add 1 it's going to add 1 to 6, making it 7. To round this number to three significant figure, you write first number, second number, and weight. This number is 6, but the number before it is just 4. 4 is less than 5, so you are not going to add anything. Instead of all those numbers, the remaining one just put zeros. In order to save the time, I have done all the operations, and I will show you now here how to round your answer to three significant figures. In order to round this answer to three significant figures, also you are going to copy 2, 3 and look for 6. Is it going to add 1 or no? Yes, it will. So the answer will be 238. And this one, 11 point. Is 9 is going to add 1 to 2? Yes. So it will be 11.3. Here, you write 3.4. And you look for this number. Is it going to add 1? No. So you are going to copy it as it is. This one, 0.0043. Now, how many significant figures we have? We have two significant figures. To make it 3, very simply, you can add 0. Nothing will change. This number, I need 3 significant figures. So I'm going to copy the first 2 and look for the fourth one. Is it going to add 1 here? No. So just ignore all those numbers and write 2. Here, 4, 0, 0. If I leave it like this, it will be only one significant figure. In order to make it 3 significant figure, just put point here. And this number is 2, so it's not going to add any other value here. This value is already rounded to 3 significant figures, so we'll leave it as it is. Also, I have solved those questions without rounding, and we will do the rounding together. In order to round this number to 3 significant figure, I will write 3 point, and you will look at number 4. Is it going to add 1 here? No, because it's less than 5, so you will copy it as 3. Okay? In this number, I will write the first 2 numbers and looking for this. Is 1 is going to add 1 here? No, so just write it. This number is rounded to 2 significant figures. If you want to make them 3, you will add 0 on the right hand side. To round this number, I will write 5 point. You look at the place number 4. Is it going to add 1 here or no? Yes, because it's 5, so it will be 9. It will raise the 8 to 9 and ignore every other number. Thus, I will write 4 point. Is 4 is going to add 1 here? No, so just write it 0. 2.32. Is 9 going to add 1 here? Yes, so I will write 3 to 1. No, I will leave it like this because he's asking for 3 significant figures only. You need to round this number to 3 significant figures, so you can just add 0 here without any change in the number. In order to round this number to 3 significant figures, 0.0, we are not counting, 1 significant figure, 2 significant figure, 3 significant figure, other numbers should be ignored. Here, I will write 15.0. 7 is more than 5 is going to add one number here, making it 9. 0.32 is 7 is going to add 1. Yes, I will write 1. Those operations, we can do quickly the number of significant figures. Okay, here are all the answers for the previous questions. Let's go to the next part of our revision sheet, which is about accuracy and precision. Accuracy, how close a measurement is to the correct answer or to the accepted value. While precision is how close a measurement is to each other. Look at each target and decide whether the hits are accurate, precise, or both. This question is asking about the precision and accuracy. By looking at the first target and the hits, you will find that they are all close. This means that they are precise and they are in the center, so they are accurate. So accurate and precise. Here, they are very far away, so they are not accurate. Very far away means they are not precise, and they are not on the hit, not on the target, so they are not accurate as well. Those hits, they are precise because they are close, but they are not accurate because they are very far away from the target. A student doing a lab, he found the density of a piece of pure aluminum 2.80 gram per centimeter cube. The accepted value for the density of the aluminum is 2.7 or 70. What was the measure of the percent error of the student here? First step, you need to calculate the error. Error equal, again, measured value minus accepted value. The measured value of the student is 2.8 and the accepted value is 2.70. So the error equals, okay, 0.10 gram per centimeter cube. Second step, you need to calculate the percent error. Calculate the error, write the formula first, because you might have 6 or more than 6 marks for a question like this. So writing the operation help you to collect some points. So the error, which is 0.10 divided by the accepted value, which is 2.70, and multiply by 100, you will get the percentage error. The answer here will be 3.7%. Don't forget that you should round your answer to the correct number of significant figure, which is 2 in our example. This question, a student took a calibrated 200 grams mass, weighed it on a laboratory balance, and found it threads 196.5 gram. What was the student percent error? It's clear here that this value is the correct value or the accepted one, and this is the measured one. So we are going to work normally, calculate the error, which is equal the measured value minus accepted value. The measured value is 196.5. The accepted one is 200. You will get a value of minus 3.5. Don't forget to round your answer also to the same number of significant figures. The small significant figure here I have 4 and this one has 4. So in order to make this 4, just put 2 zeros here. And then calculate the percent error equal the error value divided by the accepted value multiplied by 100 equals error 3.5. No need to write the minus because we are calculating percent. accepted value is 200 multiplied by 100. You will get an answer of 1.75%. Again, we need to round our answer to the correct number of significant figure because we have here 3.5 has two significant figure, so we need to change this number into two significant figure. 5 is going to add 1 here, making it 1.8%. Accuracy is often expressed as an average of several measurements. Look at the target to the right. In your opinion, how well do the measurements on the target represent? And we are done this question. Okay, and then you are asked to define accuracy. Accuracy is how much measured value is close to the accepted value, while precision is how close to each other is a number of measurements. I hope you will get benefit from this video, and I wish you all the best in your exam. Thank you.